The last word problem for the review for test 4 says a microwave has a frequency of 197 gigahertz. Find the wavelength of the wave and the energy of a microwave photon. Alright, so go ahead and pause, try to solve this, and when you're ready, unpause. Alright, so let's write down what's given. Only one number is given, 195. Giga is 10 to the 9. So gigahertz. So that's our frequency. And that's all we're given. And part A, we want to find the wavelength. And part B, we want to find the energy of a particle of light. So what's happening is that light is a wave. And it's going to travel at the constant speed c. So we also know that c is going to be 3 times 10 to the 8 meters per second. And we know the rate at which the light is vibrating, so that's the frequency, the 195 gigahertz. And we're trying to find the wavelength of the wave for part A. So the equation is wave velocity is equal to frequency multiplied by wavelength. And so we can use that to find the wavelength. So the wavelength is going to be the speed of light over the frequency. So that'll be 3 times 10 to the 8 divided by 195 times 10 to the 9. And that will give you a wavelength about 1.54 times 10 to the minus 3 meters, or about 1 millimeter, 1.5 millimeters. Okay, so next, instead of looking at light as a wave, we're going to look at it on an atomic scale, where light is going to behave like a little particle, so a particle of light or a photon, and we want to get the energy for this particle of light. So the particle of light has a frequency f, and we're trying to get the energy for that little marble of light. So the equation is going to be energy of a photon is going to be Planck's constant multiplied by the frequency of light. So this is just a plug-in here. So the energy of the photon is going to be Planck's constant, which is 6.626 times 10 to the minus 34, and multiplied by the frequency, which is 195 times 10 to the minus 9. And you get that the energy of one particle of light is 1.29 times 10 to the minus 22 joules. So on an atomic scale, that's going to be the energy of a particle of light for a microwave.